All right, Caitlin, I realized you needed a little bit of help with lesson 70 with probability. So let's begin. So let's think about what we have here. We have a fair coin is tossed 3 times. What's the probability it would come up heads all 3 times? So let's think about a coin. What opportunities do we have with a coin? When we throw it up in the air, we have the opportunity for it to land on heads. We have the opportunity for it to land on tails. That's it. We have 2 options. So every time it lands, it's going to give us one of those 2 options. That's the fraction we're looking for. That's the value. That is the probability regardless of which one it lands on. It's a 1 out of 2 chance. You might also say 50-50, right? Because half of 100 is 50. We'll say that for 1 out of 2. So what's the probability that it will come up heads all 3 times? So we have the probability, that's how we write it, that it will be heads, heads, heads. So the chances that it'll be heads on the first flip is 1 out of 2. The chances, excuse me, I don't know what that happened. The chances it'll be heads on the second flip will be 1 out of 2. And the chances will be heads on the third flip will be 1 out of 2 as well. So when you are asking for the probability that something will line up a specific way, you put the probability for each individual event and then you multiply them together. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So the probability that it'll be heads, heads, heads is 1 over 8. All right? So that is the answer to number 11. And that's how you have to think about it. Individual events multiplied against each other are working together. Okay, and the working together part is the multiplication. All right, so let's look at the next one. In this next one, we have an urn. I'm going to draw an urn here. There's my urn. And in this urn, I've got 6 pink marbles. 1, 2, 3, 4, 5, 6. And I've got 7 blue marbles. All right, so I have 6 pink and 7 blue for a total of 13 marbles, right? So we say that a marble is drawn and dropped back in. That's great. So we still have the same marbles we had to start with. A second marble is drawn and dropped back in. That's great. We still have the same marbles we started with. Both of those are pink. That's great. That's wonderful. They're both pink. If another marble is drawn, what is the probability that it will be pink? Well, the fact that the ones that were drawn and dropped back in were both pink has absolutely no bearing on this next marble. We're not asking what is the probability that all 3 will be pink. It's asking what is the probability that this roll or this draw will be pink. So the chances of it being pink are 6 out of 13 because 6 of the marbles of the total 13 are pink. So that's your answer, 6 out of 13. Okay, let's look at the next one. A single die, that's a dice, is rolled 3 times. What's the probability that the next roll will be a number greater than 4? So when we roll a die, 1, 2, 3, 4, 5, 6. Those are the faces of the die, right? But they're just in dots. Well, we want what's going to be greater than 4. Well, first on the bottom, we have to write our total options, and we have 6 options total. The ones that are greater than 4 are 5 and 6. So we have 2 out of 6 options. And whenever, this is true in math, regardless of which subject you're in, whenever you have a fraction, reduce it. If you can reduce it, reduce it. So our probability that the dice when it's rolled, or the die when it's rolled, will be greater than 4 is 1 out of 3. All right, that's the answer to 13. Let's look at 14. All right, so we have 2 die that are rolled. So in order to understand the rolls of 2 dice, we need to create like a little chart to show us what they are. And understand. 1, 2, 3, 4, 5, 6. Those the faces of the first die. So it's die number 1. Okay. Die number 2. 1, 2, 3, 4, 5, 6. So that's die number 2 right here. I'm just going to put D number 2. Now, when this one and this one is rolled, I think they get added together, they get 2. All right, that one's 3, that one's 4, 5, 6. And when 6 and 1 are added together, we get 7. So you can see we just move on from here. 3, 4, 5, 6, 7, 8. We're just adding the faces of the dice together. And it makes a cute little pattern here where your numbers are on a diagonal. All right. So those are all the opportunities for the totals of the 2 die when they're rolled. So now let's look at our problem. 2 dice are rolled. What is the probability that the sum of the numbers is 4? So for 4, we look. We know we have 36 possible outcomes. You could count them, or you could say 6 times 6 is 36. So we have 36 possible outcomes. What are the chances that the possible outcomes will total 4? We have 1 here, 1 here, and 1 here. That's 3 possible outcomes. So 3 over 36, which when we reduce that fraction, because we always want to, that's going to be 1 out of 12. All right, B, greater than 9, right? So now let's look at greater than 9. So we have a 10 here, which is 6 and 4, 10 here, which is 5 and 5, a 10 here, which is a 4 and 6. And then we have 6 and 5 here, and 6 and 5 with the dice, 1 being 5, 1 being 6, and then the other one being 5, and the other one being 6. And then we have both of them 6, which would give us 12. We have 6 chances that it would be greater than 9, right? So 6, let me get a darker color, 6 out of 36 chances that it'll be greater than 9, which when we reduce that becomes 1 over 6. So those would be your answers for that. I urge you to put this like on the back cover of your notebook somewhere so that you have a quick reference for whenever you come across this problem, because we're going to have this problem again. Until the end of the year, we're going to see when 2 dice are rolled problems on various worksheets and homework and tests. So definitely give yourself a reference so you don't have to write this out every single time. All right, so let me clear the page. Let me see. I don't think we have. All right, we have one more. 2 dice are rolled, so I'm just going to erase this and leave my dice thing up. So let's look at number 15. An urn contains 5 green marbles. So we got another urn right here. And it contains 5 green marbles, right? 1, 2, 3, 4, 5. And 9 purple marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 green and 9 purple. That gives us a total of 14 marbles. A marble is drawn and dropped back in. Second marble is drawn and dropped back in. Both were green. If another is drawn, what's the probability that it will be green? It doesn't matter that these others were drawn except for the fact that they were put back in. So because they were put back in, everything remains the same. We still have 5 green and we still have 9 purple. So the chances that the next one will be green is 5 out of the total of 14 marbles. So 5 over 14. Okay. So here's our other 2 dice are rolled problem. That's why I left this up. 2 dice are rolled. What is the probability that the sum of numbers rolled is 6? So 6. That's what we're looking for. All right. So we have 1, 2, 3, 4, 5 probabilities or 5 chances that it'll be 6. So 5 out of 36 times, right here, that's our probability. And that's why it's handy to have this written out, because then you can just look. Oh, look, there's my answer. Count it out 5 out of 36 times. Now we can clear the page and get rid of all this stuff, because that's all of the 2 dice are rolled problems. Now this says a spider. This should have said a spinner. Miss Tracy's typing isn't the best. Usually the system catches my errors, but because spider is a real word, it didn't catch that. So a spinner, so it's going to look like this. It's a spinner with spaces 1, 2, 3, and 4. Right, we got a little arrow in the middle that spins it. So we got a spinner with spaces 1, 2, 3, and 4. It's spun 3 times. What is the probability that the spinner stops on 2, then 4, and then on 3? So let's look at our probability. We have 4 possible outcomes. 2, the chances of it landing on 2 is one of those 4 chances, so 1 over 4. The possibility that it lands on 4 is 1 out of 4. And the possibility that it lands on 3 is 1 out of 4. 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. So 1 out of 64 times is your probability that you're going to get 2, 4, and then 3. All right. Let's erase that. A fair coin. Okay, so we got 2 possibilities, heads or tails. It's tossed 3 times. What is the probability that the first time it comes up heads and the next 2 times it comes up tails? The probability that it'll be heads is 1 out of 2. The probability that it'll be tails is 1 out of 2. The probability that it'll be tails again is 1 out of 2. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 1 out of 8. All right, let's look at the very last one. A single die. So we have 6 sides on a die. So we got 6 opportunities. A single die is rolled 3 times. What is the probability the next roll will produce a number greater than 3? So let's look at our outcomes. 1, 2, 3, 4, 5, 6. It doesn't matter how many times it was rolled before. Doesn't matter. Every event in the roll is going to be an equal opportunity event, or an independent event. What's the probability the next roll will be greater than 3? Well, let's say you got 6 opportunities, and greater than 3, you have 1, 2, 3 that are greater than 3. Reduce that fraction. You have a 50% chance, or a 1 out of 2 probability, that the dice, when it rolls, will be greater than 3. And that's your answer right down here. I hope that this has helped you to kind of see and get your mind in gear of how probability works. Each event is independent of the previous event. But when you're looking for a specific stream of outcomes, you then multiply those independent events against each other. Okay? When you have 2 things that are working together, like 2 dice being rolled, you have to account for every combination that could happen, and then that's your denominator. Your denominator is always all the possible outcomes, right? In fact, that's what you want to look at. You want to see that the denominator is the total outcomes. And then what's in the top are the outcomes you desire, or the desired outcome. That's how you get your probability, okay? The desired outcome over the total outcome. And that's what this number represents. You have 5 out of 14 chance that you'll get the color you want, or a 1 out of 64 chance that the spinner is going to land on the spaces in the order that you want them to, or the spaces that you want in the order that you want. All right. That's how all of this works. You look at each event as an independent event, and then when you have a stream of events, you multiply them against each other. The probability results against each other. And that's your answer. Reduce that answer if you can, and that's your final answer. All right, that is all for lesson 70. I hope this has really helped you. If you still have questions, please let me know. But go back and do lesson 70 or redo lesson 69, 70, and bring your grade up, because I know that you can do this. You are a bright young lady, and this is not beyond you at all. This is well within your wheelhouse. Happy Valentine's Day, and I'll see you next week.